Finally, let's talk about operations with imaginary numbers, which can get kind of tricky very quickly. So adding to imaginary numbers, there's nothing to it. Add like terms. So if I'm adding these to imaginary numbers, that's just going to give me 8 minus I. If I'm multiplying and subtracting, so multiplying by a scalar, so I have 3 times 1 plus I minus 4 times 7 minus 2I. So 3 plus 3I minus 28 plus 8I. So algebraically, and the algebra can never be wrong. I mean, it could be wrong, but it can't disagree with what you remember from algebra from 8th grade, right? So this is just going to give us negative 25 plus 11I. So we're just treating I as if it is a variable. If I have z sub 1 squared, well, this is going to give me 1 plus I squared, and you know the formula for squaring something, 1 plus twice the product, and then I'm going to have I squared, and I squared is negative 1. So this just ends up giving me 2I. And if I'm multiplying these two together, again, I'm just treating I as a variable. Right, a variable is just a stand-in for some number, so this should work. So that's going to give us 7. 7I minus 2I is plus 5I. And then we're going to have minus 2I squared. But again, let's remember I squared is negative 1, so this becomes plus 2. So this just gives us 9 plus 5I. And dividing we need to talk about a little bit because we're not. Let's go back to that rule that I haven't really adhered to, where you can't have a square root in a denominator. And since I is the square root of negative 1, let's just practice a little bit. So I'm dividing this by this. And let's use that complex conjugate, the conjugate situation. So I'm going to multiply by 7 plus 2I on the top and the bottom. And in the top, well, let's see, I've kind of done this. I have multiplied by 7 minus 2I. So I know this is going to give me 7 plus 9I plus 2I squared. And in our denominator, these are conjugates. So I'm going to have 49 minus 4I squared. 2I squared becomes negative 2. 4I squared becomes negative 4. So this becomes plus 4. So we have 53 in our denominator. We have 5 plus 9I in our numerator. And I could write this as a complex number. There's my A. There's the B and I. Okay, and I'm going to do F on another sheet of paper here. So for F, I have Z1 cubed, and Z1 is 1 plus I. Okay, fortunately, I remember that Pascal's triangle situation. I know this is going to be 1 to the third, plus 3, 1 squared times I, plus 3, 1 times I squared, plus I cubed, which is going to give me 1 plus 3I. I squared is negative 1, so this is minus 3I. And then I cubed is I squared times I, so that's this is minus 3. And then I'm going to have minus I here. So 1 plus I cubed just gives me negative 2 plus 2I. Negative 2 plus 2I. And for G, I have to do 1 plus I to the 6th. And I could remember Pascal's triangle. Let's see, or I might remember the binomial theorem. I'm going to do binomial theorem. So I know I'm going to start with 1 to the 6th, and then I'm going to have 6 times 1 to the 5th times I. 30 divided by 2 is 15. 1 to the 4th, I squared. That's 60 divided by 3 is 20 times I to the 3rd. 1 to the 3rd, I to the 3rd. 60 divided by 4 is 15 times 1 to the 2nd, I to the 4th. And 30 divided by 5 is 6 times 1 times I to the 5th. And I'm going to end with an I to the 6th. Okay, a little bit cumbersome. So I have 1, I have 6I. I have negative 15. I have, this is I squared times I, so negative 20I. I have 15. I have 6I. And I have I squared to the third negative 1. My 1's cancel out. The 15's cancel out, and it looks like I'm left with negative 20I, negative 8I. Confusing. Negative 8I. Okay, I'm going to try this another way because I already know that 1 plus I cubed is negative 2 plus 2I. So if I want that to the 6th, I'm just going to need to square both. So negative 2 plus 2I squared. I'm even going to be a little bit lazier. I'm going to say this is going to be negative 2 times 1 minus I squared, which I'm going to say is negative 2 squared is positive 4. 1 minus I squared is 1 minus 2I plus I squared. I squared is negative 1. Those will cancel out, and again, I get negative 8I.